All right, welcome back everybody for week 2, lesson number 2. Go ahead and get your warm-up started. I'll give you about 8 minutes. Pause the video at this point. Again, number 1, 2, and 3, no calculator. Number 4, more than welcome. If you have any questions, they are very similar to yesterday's. So go ahead, pause the video. If you have to go back to yesterday's to look up anything, more than welcome to. When you're ready, unpause the video because here we go. Number 1, all we have to do is distribute and find the answer today. So a little bit easier than yesterday, no guess and check. -5 times 1n, a negative times a positive is -5m. A negative times a negative. Remember, we have that dead man strategy. I cover up my 2 negatives. That means a negative times a negative is a positive. 5 times 2 is 10, so I find the equivalent. Answer choice C, -5m plus 10. Number 2, again, I'm going to find each event. Which one is the most likely, the highest probability? The easiest way to do this is make sure they are all decimals or percents and then pick the highest number. Spinning a blue, 3 different colors. 1 out of 3 chance of landing on blue, that's about 33%. I got to try all the choices though. I need to find the biggest. Flipping heads, 1 out of 2, 1 heads, 2 sides, 50%. So automatically A has been eliminated. Letter choice C, rolling a 6 on a number cube. There is 1 out of 6 numbers that are number 6. It's approximately 16%. Again, answer choice B is still in the lead. Numbers greater than 2 on a fair number cube, well, that would be 3, 4, 5, 6. That's 4 out of 6 numbers, which is approximately 66%. That is now eliminated. Our leader B, and D is the correct answer. Again, we have to find each one. If it's asking us for the highest probability, got to try all 4 choices. Number 3. The temperature started at -8 and dropped or went down by a ½ degree each hour. And we need to figure out what the temperature is after 6 hours. So again, I put a starting point. I listed all the different hours I'd have to find the temperature for. And now I go through and actually drop the temperature. Well, again, -8½ is a ½ degree less. It goes down another degree, negative. -9 goes down again, -9½. It goes down again, -10. It goes down again, -10½. It goes down again for the 6th time. We're at -11, so -11 would be the temperature after 6 hours. Number 4, again, I added up all my data points. Today there were 6 numbers for this problem. I would get a sum of 22.37. After that, I know that there were 6 data points. 22.37 divided by 6. You should have got a mean about 3.72. There was a bunch of decimals there, so I just cut off and left it alone after the 2nd decimal place. All right, today we're going to go over how can surface areas of 3-dimensional figures be determined. Last year in 6th grade, you were given nets. This year, you will be given the actual prism that you will have to break apart, find the area of each piece, and then combine them at the end. So, up here, how can you determine the total surface area of the figure shown below? Well, I have a bunch of different dimensions. The first thing I would do is I would go through and list all of the missing pieces. So I know that any line that's running across or horizontal has a value of 12 because the top number is 12. So here's a 12, another line going horizontal is 12, and that bottom piece would be 12. Then I'm going to look to myself, well, what other dimensions did they tell us? Well, they told us that the base of these triangles has a value of 6. So again, I know if this side is 6, this side is 6. Well, they're the only 2 triangles I see, so I'm done and labeled. They already labeled the height of the right triangle. Well, they didn't label the height of the left triangle, so I'm going to go ahead right here. This dotted line tells me the height of the triangle has 2. So again, I listed the height of my other triangle. I see side lengths of some rectangles is 4. Well, again, I'm going to label all the sides that I need 4. Once I've labeled everything, now I can actually take these apart and find the area of each piece. Well, I think to myself, how can I find the area of rectangles? Well, rectangles, I know that I can use my formula area equals length times width. Next up, I broke out 3 different rectangles. There's a top, a middle, and a bottom rectangle. So I'm going to even label them as top, middle, and bottom. And however you want to do that, you can shorten them up. However you want to write them out, just TMB, that would also work. And I think to myself, well, if I trace, I think about the numbers that I go by for the length and the width. So when I trace this top one, I went by 6 and I went by a 12. So I know that this would be 6 times 12. Again, I'm going to try all 3 and see if there's any that duplicate because I can't assume that they all do. If I trace the middle triangle, I went by a 4 and a 12. That means this is going to be 4 times 12. I trace out my bottom triangle. I traced out 4 and 12 again. Now I can actually go through and do the math real quick before I move on to the triangles. 6 times 12 is 72. 4 times 12 is 48. 4 times 12 is 48 again. So I have my 3 rectangles done. I still have to figure out the surface area or the area of my triangles because it wants the entire area of this picture. So again, I went down, I drew out 2 triangles, and I thought to myself, well, that uses a different formula. So off to the side, 1/2 base times height, or again, base times height divided by 2, that's up to you. I go to that triangle in that piece, and I'm trying to locate what is the base and the height. Well, if I find that right angle, there's my right angle, I have a base of 6 and a height of 2. 1/2 times 2 times 6. 1/2, both triangles are going to be the same. They're opposites, they're congruent. 2 times 6 is 12, half of that is 6. Both triangles are going to be 6. The last thing is they want the total surface area. So I can go back through here, and I'm just going to erase some stuff that I've already put up here, and just kind of list all the different pieces areas. I know that this rectangle had a surface area of 72. I know this rectangle was 48. I know the bottom rectangle is 48. And I knew both my triangles were 6. Well, total surface area would be to add all their areas together. 48 plus 48 plus 6 plus 6 plus 72. I need my calculator. So again, I'm doing 6 plus 6 plus 72 plus 48 plus 48 would give me a final total of 180 feet. So again, 6th grade, this is what you did. They gave you a net. In 7th grade, it's going to be really important that this is a triangular prism, that you're able to unpack or unfold that triangular prism, list all the different shapes that make up that triangular prism, and then solve it just like you used to. So, right here, at this point, I would type in this bit.ly virtual nerd. If you want another example, virtual nerd, capital S, capital A, capital V, capital N, capital S, capital A. This will take you to a virtual nerd video. I'll pull it up real quick just so you can see if you're in the right spot. Should pull up how do you find the surface area of a rectangular prism using a net. I gave you an example of how to do using a triangular prism with a net. This lady goes over how to use a net and go over a rectangular prism. So again, the video is about 7 minutes long if you need another example from 6th grade. Okay, back to our work for today. Up here, a couple of notes. So topic is surface area. A net is a flat shape which can be folded up into a 3-dimensional figure. If you've ever done origami, very similar to that. They take a flat piece of paper, they construct it, it becomes a 3-dimensional figure. Surface area is the total area that a surface of a 3-dimensional figure has. So it's the area of all the total surfaces. And then real life surface area, when you go to wrap at present, wrapping paper is sold usually in square inches, square centimeters, squared units. So basically, if you know the area of a gift, you could find out how much wrapping paper you actually need. So up here, complete this chart. What shapes do you see that make up these 3-dimensional figures? The first thing is knowing your 4 different shapes will go a long way, because what's true about these is often what's true as far as the number of squares, rectangles, and triangles. Now, squares and rectangles without dimensions is a little bit debatable, because some people might see it as a square, some might see it as a rectangle, but as long as you're seeing it as a 4-sided shape, that's kind of the takeaway from this part. So, we have a triangular prism. The first thing that I notice is that it has 2 triangles, one in the front, one in the back. So I'm going to list that as 2 triangles. Then I think to myself, well, I know that each side of the triangle has a rectangle or a 4-sided shape. So in this one, I don't see anything that looks like a square, so I'm going to say 0, but I'm going to say that this left side, this right side, and definitely the bottom are all 4-sided shapes, rectangles. So a triangular prism has 5 shapes that make it up, 2 triangles, and then 3 4-sided shapes, either rectangles or squares. Figure number 2, this is a pyramid. Pyramids are always, the base is made up a 4-sided shape. This one looks like a square. It could be a square or a rectangle. Again, without knowing dimensions, we would just be guessing or assuming some stuff. Each side of the rectangle or the square also has a face of a triangle. So there's a front and a back that are triangles. There's a left and a right that are triangles. There are 4 triangles. And if you said this guy was a square, then there are no rectangles. You could have said that there are no squares and maybe 1 rectangle. Quick break for an announcement.
Ms. Lepore or Mr. Gray, please come by Ms. Diaz's office. Ms. Lepore or Mr. Gray, please pass Ms. Diaz's office.
So figure number 3, this is a rectangular prism. We know this because it is made up of all 4-sided shapes, either squares or rectangles. The top and the bottom, I'm going to call everything a rectangular prism, but they do look like squares, so it is possible. So you could have said 2 squares, there's definitely no triangles, and then 4 rectangles, or you could have said that there's no squares, there's no triangles, and that there's 6 rectangles. Again, without dimensions, we're just debating what's a square and what's a rectangle, but the important thing that you understand is that when you unfold a rectangular prism, you have 6 4-sided shapes. And last one, this is a cube. Cubes, the definition of a cube is 6 squares. Think about a die or a dice. If we put numbers on there, that would be a 6-sided die. There are no triangles, and if it is called a cube, there are definitely no rectangles in there. So again, knowing these 4 geometrical shapes will go a long way to helping you be able to break them apart, list their areas, and find their surface area or their volume when we get to it. All right, first up, I have an example of a rectangular prism, a triangular prism, and a pyramid. After that, it's going to be straight to the classwork today. These do take some time, so we kind of limited the number of practice problems today. Please take your time, make sure you're showing your work. These are not difficult, but again, they take some time and some prep to make sure that the math is easy. First thing, determine the surface area. Well, again, I see a rectangular prism. I know that in rectangular prisms, they are made up of only squares and rectangles. So the only formula I need is area equals length times width. I even like to start kind of putting shapes around my letter A so that, hey, I know that I'm dealing with 4-sided areas, length times width. The next thing I did is I looked at this. Well, there's 6 sides to a rectangular prism. Think about a shoebox. There's the lid, the bottom, the left, the right, and the front and the back. So that's exactly what I'm going to do off to the side. I'm going to list all the different dimensions they are. So I drew 6 rectangles, and I'm even going to label them what they are into the picture. So I have a top and a bottom. I have a left side, and I have a right side. I have a front, and I have a back. And even if it's something as just kind of basic labels to let you know, hey, these are the 6 sides that I'm dealing with. The next thing that you're going to want to do is actually pick a starting point. Now, what's nice about geometry is anything that has an opposite congruent side, you already know the value of. So if you know that the top and the bottom are the same, you try to find the dimensions of one of the 2 sides, and then you just double it, knowing that they're going to be exactly the same. Well, I look at the top of this picture. There are no values. So I need to look at the bottom and see what information did they give me. Well, if I trace the bottom, it looks like I go by 2 numbers, 3 and 3. That must mean that it's a square. So I know that the bottom is going to be 3 times 3, which is equal to 9. But I already know that the top is also going to be 3 times 3. Because again, the top and the bottom are exactly the same. If I were to trace the top, these 2 lines are geometrically symmetric in geometry, so they have the same value. So this is 3, and any line that's being diagonal also has a value of 3. Again, if I were to trace this out, I go by the dimensions. 3 times 3 gives me exactly 9. Let me erase that part. Move on, pick a side, the left or the right. Well, sometimes I've got to trace both sides to find the length and the width. Maybe the length's on one side and the width is on the other. So if I trace this left side, I clearly go by the value of 6, but all these other dotted lines or this other slanted line don't have a number. So I know that the left side is going to be 6 times something, and the right side is going to be 6 times something. Because again, any of these lines going up and down automatically have a value of 6. So let me trace out the right side. Maybe I'll get the width on that side. I trace out, well, I don't go by anything. I keep tracing. I just went by 3, just double check. Did I go by any other numbers? No, I didn't. That means the left and the right must both be 6 times 3, which has a product of 18. Okay, so far so good. Last, what do we have left? We have the front and the back. Again, I'm going to trace one, see if it gives me any information. If not, I'll trace the other, see if I can combine the information. Let's start with the front. As I trace the front, I go by a 6. I trace the bottom, I go by a 3. That must both mean they are 6 times 3s, which are also 18s. Okay? Once I have the surface area of everything, I can go ahead and add them up. So I would do 9 plus 9 plus 18 plus 18 plus 18 plus 18. Real quick, I need my calculator again. And I would have a total of 90 square feet. Again, first step, list out all the different shapes, break them down, go ahead, trace them out, find each piece individually.